Google was a tremendous place to incubate this idea. What we're trying to do is change how people, in particular, heat their homes. And we're doing it in a way that has a lot of old school elements. It's not all software. Part of what being separate has allowed us to do is do all the things that small companies do, which is iterate quickly, improve your products quickly, and constantly respond to both the needs of customers and also ideas that are going to help you advance the product.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about geothermal home heating systems and how new innovations may be making their advantages more affordable for you. I'm a huge fan of geothermal. I've interviewed the Department of Energy twice about the work they are doing to bring enhanced geothermal to parts of the country not blessed with naturally occurring geysers. Now that was for utility-scale energy production. These home heating geothermal units have been popular since the late 1970s, and it's estimated that about 80,000 new units are installed in the United States every year. But my guest says they are still pricey and difficult to install. The typical design requires coils of tubing to be placed in your yard, which requires all that surface area to be dug up like a shallow swimming pool. There's a vertical design, but that requires a tracked drilling rig that will probably also trash your yard once it's done maneuvering into place. The bottom line is that a lot of this technology was designed for other purposes, specifically the drilling equipment, which is more efficiently used on bigger projects than your home on Willow Drive. My guest says they started off specifically to address the needs of home users. Their drilling rig is much smaller, and they only drill vertically for those homeowners who have limited space in the backyard. They say that their genesis with one of the world's biggest companies was also a benefit. By lowering the cost of ownership and logistics of installing such a system, geothermal should see a broader role, both for baseload power and right under our feet. My guest today is Michael Saxe, CEO of Dandelion Energy, a home geothermal provider based in New York City. Dandelion started off as an idea incubated by Google X, the moonshot department of the internet giant. In fact, one of the reasons why Google changed its name to Alphabet, which we all use, right, was because of ventures like this. Dandelion left the fold in 2017 and became its own company, though Michael says Google is still an investor. I hope you enjoy my conversation with Michael Saxe. We're here with Michael Saxe, CEO of Dandelion Energy. And Michael, my stepdad worked in the HVAC business for a long time in Louisiana. The owner of that place, I'll never forget, installed a geothermal home heating system at their house. It was kind of like a sprinkler system. They dug up trenches in their backyards, laid pipe. So Dandelion Energy, here we fast forward to now. How is this different from one of those conventional geothermal home heating systems that maybe some people are familiar with who are listening today?
Sure. Great to talk with you. And I also have Louisiana roots, so that's fun to hear about as well. What Dandelion is doing is we're making geothermal available to, for lack of a better term, the suburbs. Typically, geothermal was available if you had a lot of land and could run essentially a lattice work of geothermal loops, or frankly, if you're pretty wealthy and could afford to have someone come and drill vertically for you. The question we started with was, why is this so expensive? Can we find a way to make it cheaper? And that's what we've been doing, and really doing it in a few ways. One, our roots are in Google, so we are all about analyzing and getting value out of the data, and we've been able to do that quite effectively with geothermal. Two, we realized that folks were bringing the wrong equipment, and that a lot of it is about getting equipment that will not disturb suburban home being retrofitted. And then third, we have a proprietary heat pump that really is part of that data story. It allows us to see how the home's using energy technology, and then in turn helps us build better products in the future.
That's kind of what I figured, was that it was going to eliminate the need for a lot of surface area or a lot of a big backyard to work. It seemed like systems have understood them to be in the past required that kind of surface area. You couldn't install these in an apartment block, for instance. There's just not enough open ground. So what are you doing differently there? You're just drilling vertically into the ground?
Yeah, that's right. We're drilling vertically, and we aren't the first to do that, but we're drilling vertically with much smaller equipment that's really built for this purpose. When you go to someone's home, they have a yard they care about. They have a driveway. They don't want you to roll over and break things. And one of the things that we've really optimized our equipment around is being able to get into small yards. We've custom designed a tracked rig that can do that vertical drilling, but also can do it with minimal disturbance to an existing yard. It needs about 11 feet for a turning radius. Typical had been 43 feet. It weighs about half as much. Really doing all those types of things to just shrink everything down has been a big part of what's allowed us to offer this to a typical freestanding home.
What's the statistic? You go a certain number of feet down and the temperature is uniform for what would be the temperature for the rest of the year, right?
That's right. The temperature of the Earth is going to vary between 50 and 55 degrees. That's important because in the summertime, that's going to provide a source of cooling. And in the wintertime, that's going to provide a jump start on heating. And the purpose of what we're doing is we're trying to access that constant temperature and then create a heat exchange so that we can bring it into the home.
And how deep are you drilling down? Because I've lived in Louisiana where you could drill to the center of the earth and you're not going to hit rock. And then I've also lived in Pittsburgh where you're going to hit rock after probably the first 3 or 4 feet. So what about those considerations?
Yeah, that's one of the things we think a lot about. One of the things that's been a challenge in geothermal is that it's been kind of a one-size-fits-all approach. I liken it to the Empire State Building. Great building, absolutely iconic, but you'd never build it today because it used about 3 times the concrete and 3 times the steel that it requires to support a building like that. For us, a big part of what we do is we really bring a lot of data to understand the thermal conductivity of the soil we're going into. And we treat Louisiana, or for that matter, a place like Long Island, where you have unconsolidated soil pretty much all the way down, differently than we would a place like Pittsburgh or where we work up by Albany, where the bedrock's going to be pretty close to the surface.
And Michael, you mentioned Google earlier, and this is something that I was really interested in as I was researching you guys. You were spun off as a division of what was formerly called Google X. Since they've been called Alphabet now, I believe it's now called X Development. Now, most companies get acquired by Google. In fact, a lot of them, their business strategy is to ultimately do that, but you're the other way around. First of all, what's changed since you're no longer under that? Everyone still calls it Google, but Alphabet umbrella.
Alphabet was a tremendous place to incubate this idea. And Google, both the company and Google Ventures, are both investors in Dandelion. But really, we've gone solo because our mission is a little bit separate from theirs. And frankly, while Google's an amazing company, I think they're an unlikely acquirer of Dandelion. What we're trying to do is change how people, in particular, heat their homes. And we're doing it in a way that has a lot of old school elements, as you and I were just discussing. It's not all software. There is drilling involved. Part of what being separate has allowed us to do is do all the things that small companies that are nimble and making their way do, which is iterate quickly, improve your products quickly, and constantly respond to both the needs of customers and also ideas that are going to help you advance the product.
I would think also one of the things you would have to worry about a little bit more now than you would when you were under Google is the financing. It seemed like the financing would always be available if you're working for Google.
That's right. I mean, like in some ways,
you live in the real world now.
That's right. I mean, one way to think about it is like being part of Google is almost like being part of the government. It just seems like there's endless access to capital. But that's part of what's great about starting a business is like you're constantly forced to stand on your own 2 legs and figure out what that means. And it makes you smarter, I think. And it's been a really good experience for us.
Were you there during the Google X phase of Dandelion? Can you at least tell us what it's like working during those Google X years? What is that incubator like? It seemed to me from what I was reading that they incubated just about any idea that they could think of. How did they decide what got funded, what got incubated, and just what was that environment like?
I joined the company in January after we had been spun out. Look, their bar for a great idea is incredibly high. They want things that are going to make an enormous impact. And then the way that gets rewarded to them is the same way that a lot of venture capital firms operate, that one really big idea can pay for 9 failed ideas. Our hope is that we're successful enough that we're funding effectively the next generation of ideas within Google.
Yeah. Getting back to Dandelion and today, more about the technology, how much energy savings can a typical consumer get from this? If you lived in the Northeast or North Dakota, for instance, how could you sustain entirely on this system for heat? And I think you kind of said, at least on the heating side, you're 50 degrees, it gets it going, right?
Geothermal is a great option, frankly, both for heating and cooling. The impact is different. Geothermal is going to reduce your heating bill by 80%. That remaining 20% is essentially going to be the electric cost of running a ground source heat pump. For air conditioning, it's going to reduce your bill by 30%. So still a big improvement, not quite as dramatic. In a lot of ways, the challenge for us has been how do you align those savings with the fact that it takes a little bit more in upfront cost to get it installed.
Have you come up with any financing options that make that attractive? How people can square that upfront cost with what their normal bills are?
Yeah, and that's very much how we think about it. More than half our customers finance, and the financing is designed to be zero money down and make sure that your average energy expenditure on a monthly basis is lower than it was before. It's something we've brought to market. And frankly, as more potential lenders see this as a solid investment from a debt perspective.
How fast before the typical residential customer can reclaim the cost?
We typically see a 5 to 7 year payback. Right now, that's primarily for homes that use fuel oil or propane, who really have more expensive heating bills. But part of what we're doing is we're working every day to bring the cost down. One way we think about that is for every $5,000 we can take out of the cost, that's going to bring another 15% of the natural gas market into play. It's going to take a while, but that's really the way we're headed.
This reminds me a lot of rooftop solar. You're trying to go green. Are there incentives in place for homeowners, same as you can basically get a rebate for the entire cost of a rooftop solar system? What's out there?
It's very similar in that sense, very similar in terms of how the financing works and how there are some incentives that help to lower the cost. And frankly, we have a lot of people in our company who were at Solar City, so we've imitated a lot of what they've done. The one thing that I think is an important difference is with solar, you're going to have electricity no matter what. You're never going to need to do anything to replace your electricity. So it's always an optional purchase. Whereas with geothermal, our view is every customer is going to come into the market eventually because their furnace isn't going to last forever. There's a natural replacement cycle that customers are going through. And so we think we have a chance to be part of that. But in other ways, you're exactly right. The comparison to solar is very strong.
As someone who grew up in the South and spent most of my life in the South, places like Texas, I'm in North Carolina now, which is a little bit more mild. But what about air conditioning? You said about 30% savings on air conditioning. How exactly does that work? Is the water going into a single system that's providing both the heating and the cooling?
Maybe just to step back on what's actually happening. We're drilling 1 to 2 bores. The bores are going to be 370 feet deep on average. They're going to be 4.75 inches in diameter. And then we're going to put inside each of those bores what we refer to as a ground loop, which is really HDPE pipe with a U-bend at the bottom. And that's going to be connected into the home, connected into the heat pump, and then filled with water with a little bit of glycol to prevent freezing. In the wintertime, what's happening is you're bringing that 50 degrees up, and that's a jump start for the heat pump to spread warm air throughout the house. And really during the summertime or in a warmer climate, it's going to run in reverse and bring the heat down back into the earth, and then in the process, bring the water that's been cooled back up.
And look, not only do I live in Texas, I'm curious why only now this is being considered as an option. My gas bills in Pittsburgh were outrageous in the winter, like $500 a month. Was there an underlying technological breakthrough to get us here other than just the rig and its size?
It's interesting because it's something we've thought about a lot. I think there are a few things that are happening together. One is the status quo has been that if you want geothermal and you're not doing it horizontally, a contractor would call a well driller and it would be be effective, but messy and they'd tear up your yard. Now, the reason why are those guys using that equipment? Well, either their business isn't just geothermal, it's geothermal and well drilling, or if it's just geothermal, the core of their business would be commercial jobs where you go in and drill 80 bores and you're busy for 6 to 8 weeks. For us, one thing that's unlocked this opportunity is just the ability to find and attract people over the internet. I think a decade ago, you couldn't have gotten people to buy a product like this effectively online. We, of course, talk to them and look at the home, but it's a virtual sales process. The other thing that's really key is we've been able to bring data to this in a way that it just simply wasn't available before. The fact that we're able to do this, and I hate to use the cliched term, but almost in an Internet of Things way, where we're seeing how the heat pump's performing in the home, and that allows us to improve what we're doing. That's also unlocked a lot for us. Of course, both those things allow us to go with smaller equipment because we know we're just going to do residential jobs, and that's been a factor as well. But really, I think the consumer behavior over the internet and the availability of data coming off the heat pumps are the big things that have unlocked it.
Michael, how large are your systems and how large could they be? I'm a huge fan of geothermal. I've covered geothermal on the show on the utility scale, but I imagine you can develop operations for large communities, campuses, or commercial facilities. Any chance of expanding it to the point where you could take this idea and expand it to more than a single family home?
That's one of the things that I think is really exciting in the space. I don't know if it'll be us who does it or someone else, but I think someone's going to do it. We're in talks with a lot of production scale home builders or community builders, not necessarily single family homes, looking at how we could set them up with geothermal. And really, if you're doing it up front, it lowers the cost in some meaningful ways. And it's such a tremendous source of not just heating and cooling, but also protection from variations in gas prices that we're seeing a lot of. I think it's something that there's no per se limit on how big you could go with this.
What's your plan for expanding? And like we talked about, it sounds to me like you're also looking into doing larger, more community-based operations. What's your plans?
Right now, we're in New York and we're also in Connecticut. We're going to expand further into Connecticut, go to Massachusetts. And while I know it's part of New York, we're also going to go to Long Island. If you're in New York, it seems really different. That'll be next year. And then from there, I think we will be expanding throughout the Northeast, but particularly in combination with some of those home builders, perhaps in Maryland or Delaware would be our next steps. But we really think this is a technology that can work anywhere that people are experiencing a lot of temperature variation, and we're excited to build it.
Yeah, it's so simple. It really falls in the why didn't we think of that category, right?
It's one of the things where when you're building a company, I think one of the things you always think about is like, well, what's our unfair advantage? And we have a few in that we have some pretty valuable data sets around how homes are performing and different soil conductivity. But one of those advantages is just that we got a huge benefit from being incubated within Google. And one of the things that's amazing that's happened in the economy is that it's become so cheap to innovate with software. It's still kind of hard to innovate with hardware. And Google kind of gave us that jump start on doing that. And we just feel like we've been able to come to the market with something that customers really want and hopefully can improve it a lot from there. It's an exciting time.
Yeah, very exciting. Very excited for you. Michael, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Fuel that is going to be used less and less, and it's a tough investment for utilities.
Crude oil.
It's an important part of the mix, but again, I may be Johnny one note on this, but I think it's really critical we get off fossil fuels.
Nuclear.
I think it's got to be part of our solution set. I think we need it.
Coal.
Same thing. A lot of our infrastructure is dependent on coal, a lot of jobs dependent on it, but I think its days are numbered.
Wind.
Great technology, relatively mature industry. I think we know how wind's likely to perform.
Solar.
I think we're just scratching the surface with solar. 3% of American homes. I think we can do a lot more.
Hydroelectric.
It's a clean, renewable fuel. I think it's an important one.
Geothermal. You guys.
I'm deeply in bed with this one. I think it's the solution to all our problems.
Energy storage.
I think it's around the horizon. I think we're going to solve that this decade.
Electric vehicles.
Only cars any of us will drive in 2030.
Energy efficiency.
It's the first fuel.
And finally, fusion power.
The answer to all our problems, or perhaps an impossibility.
All right, Michael Saxe, Dandelion Energy, thank you so much for your time.
My pleasure. Really enjoyed it.
That was Michael Saxey, CEO of Dandelion Energy, a home geothermal developer based in New York City. I want to thank Michael for his time, as well as Sam Boykin at 360E Communications for setting this up. You can find plenty of pictures for this episode at energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 103. Be sure to join us next week when we discuss the emerging energy trends from one of the nation's leading energy efficiency providers. Until then, I'm Jay Downhauer. We'll see you next time.